Okay, so in this video I'll be connecting up 450mm copper cables. So how you approach generally most jobs like this is to start by stripping the cable. And this is a fire rated cable, so the outer sheath is quite thick, obviously fire resistant. It can be a little bit of a ball ache to remove, but this wasn't too bad. And beneath that is a wound fibrous plastic that comes off pretty easily. And then you have the ground of the earth, which is stranded copper, and underneath that is like a sort of a copper band. It's like a wound band or something likened to that, and I think that's more for thermal and mechanical protection than it is in forming the actual ground. But otherwise a pretty typical cable construction. Just left with the thick sort of rubber insulation. This is fire rated cable, so it's really stiff, quite difficult to get off, and it doesn't usually come off in one piece. So I've made it off, and now what I'm going to do is make it easy for myself and just jack it up a bit. And this isn't SWA, these cables aren't made off with a gland. This is typical for where I am. You just sleeve up the earth and tape them off, and that's it. So now I'm going to install some means of mechanically securing the cable, and the fixing that I'm going to use is designed specifically to work with this C channel and also the cable ladder, and it's approved for fire resistant methods of installation. The extra holes there are in fact a small mistake, as I started filming after I'd already begun and forgot what I was doing. The main purpose of this bracket is for fixing cables in the vertical position, and usually, well, depending on what kind of spec you're working to, it's every 30 centimeters. One of your greatest allies in moving big cables is always straps or ratchet straps, and my personal favorite, a big wooden stick. Got to be cognizant here of how much space I'm taking up, so I've moved them as far to the left as I can, because there's some other cables that are going to come in from the right. I just want to give myself enough space to make those off and not make things difficult. You can also see here what the cables look like when they're made off. It's a pretty sort of simple method. I've left the inner insulation on a bit long, so it kind of provides mechanical protection against the stranded copper, and you just put the sleeve on and tape it up, and that's it. So here's a look at the press I'll be using to secure these lugs to the cables. I think for the majority of the B series of dies, the bottom and top piece remain the same, and then the two inner pieces are interchangeable depending on the size of the cable lug that you're pressing. And unlike the Nova press, which presses to pressure, this is a die-based system, so it will press for as long as the dies allow. So these are tinned, plated copper lugs. They're like 99% copper, but regardless, I've got a brass brush and I'm going to give them a little touch up. This is again a dry environment, and there shouldn't really be any problems, but with the bus bars being aluminium, I just feel that it's good practice to put some contact grease in there. The surfaces are very much imperfect, and I think one of the benefits of the grease is that it will give you that absolute contact. Just a little word on the bolt and washer arrangement. You've got a bolt, washer, then you have the buzz bar, lug, another washer, and then a concave washer and a nut. Got an M10 bolt and nut here, and it's 44 Newton meters of torque, so it's pretty manageable on your own. And what I'm going to be doing then, I haven't really got much choice, is working back to front. but I'm not going to work to a predetermined left to right or right to left. I'm going to look at the cables working from the back and see how they're aligned and where I should go. And in this case, it just so happens to be that the L3 conductors for both of the back cables are towards the back, so this is kind of determining where I'm going to start. The worst thing you can do here is cut the cables too short. You just want to take your time and reduce the length slowly, and one of the methods I've found of getting the correct length is to bolt up a temporary lug close to where you're working, or next to where you're working, and just use that as a reference. So these are sector cables, and we have a round lug obviously, so what we need to do is deform or reform the shape of the conductor back towards a circle, and the way of doing this is with the insulation on, just use your pliers and ease against the hard edges. I'm going to be putting some heat shrink on the lugs, so I can afford to go a little bit past what I need to strip, and that will also help me to get a more uniform shape. I'm also going to take a little bit of the twist out of the cable from the manufacturing process, and I feel that that also helps to create a more uniform shape. Obviously the purpose being that when you press the lug, you're going to more evenly distribute the pressure, and I'd assume creating a much more reliable connection. And at least in this case, it's in accordance with the manufacturer's instructions. So this is again fire resistant cable, and underneath the insulation is like sort of a fabric, a fire resistant fabric. It leaves kind of some kind of remnant on the cable, so at least in this case I like to take a brass brush and just clean it up a little bit and make sure we have no residue on there that's not supposed to be. So it's a quick touch up, and then we're on to pressing. I think it's just about taking your time and making sure you're kind of centered. It only needs one press in this case, so it's pretty easy to get it right. The only real problem with this Elpress, I think at times, is with all the different parts. It can be a little bit fiddly, and sometimes they kind of fall off, or maybe one of the dies isn't secured properly and that'll pop out, but otherwise it's pretty easy to use, and it leaves a really clean press. So that's the process for crimping a lug, and then it's just pretty much rinse and repeat. So for the line and neutral conductors, it's an M12 bolt, and that's 70 Newton meters of torque. I'm going to be mirroring the washers on the other side, so in effect what we have is two load spreading washers and then two concave washers opposing each other. So they'll be working together to keep this secured under any sort of thermal expansion or whatever that it might experience, and it should create a reliable and secure connection for the lifetime. And then it's just a case of torquing it up. And again, just rinse and repeat. Make sure you're diligent and follow the process, and it's pretty easy really. And thanks again for watching, if you made it to the end. Okay, bye bye.